Hi everyone, and welcome to this lesson in the Linux security. In this lesson, we will be talking about managing logs with Syslog, the foundational logging system on almost every Linux system. Now, as a security professional, log files are incredibly important. They help us detect improper access, unusual behavior, or signs of a security breach. In fact, attackers often try to erase or tamper with logs to hide their tracks. So, managing and securing logs is absolutely essential. Let's get started by defining what is Syslog. Syslog is a long-standing standard for logging on Unix and Linux systems. It dates back to the 17s and remains widely used today, typically in the form of an enhanced version called Rsyslog. To verify that Rsyslog is running on your system, open your terminal and run the following command: ps aux then pipe and grep syslog. You will likely see this process /user/spen/rsyslogd that confirms rsyslog is running on your system. Logs are typically stored in the /var/log directory. You can inspect this directory with cd/var/log. Now let's execute ls-lh and you will find files like messages and secure message. So it is depending on your distribution. Because I'm working on Rocky Linux, as you see, the Syslog will store its logs to messages, for example. But on Ubuntu, you will see syslog file. Let's try viewing the messages file with tail, then the path to messages log, which is var log/messages. And as you can see, tail can't open the file for reading, permission denied. And that's because you are a regular user. That's expected because these logs are owned by root to prevent tampering. You can still view them with sudo. So I will execute the same command, but this time I will add sudo. So as you can see now, sudo tail shows the content of messages file. You can also add the option -f to the tail command, and this command will show real-time log entries. So whenever we have a new entry inside messages file, it will be shown here. Now let's press Ctrl C. The Linux system uses a tool called logrotate to prevent log files from growing indefinitely. To view the default rotation settings, let's execute cat/etc, then log rotate.conf, which is a configuration file for log rotate. As you can see here inside the file, there is weekly and rotate 4. This means logs rotate every week and only the last 4 weeks are kept. You can increase rotate to keep logs longer or implement an external backup policy. If an attacker gains root access, they can simply delete logs with, for example, sudo rm then /var log messages. Of course, I will not execute this command on my system, and that's why we don't want to rely solely on local logs. The solution is a centralized syslog server where all logs are sent and stored. Now let's see how to prepare the syslog server. So here I am on my server or the syslog server with the hostname server. First, I will enable TCP logging in our syslog. To do so, let's type sudo, then nano /etc or syslog, then conf, which is the main configuration file of our syslog. Now press enter, and it seems that I don't have nano installed on this system, so let's install nano using sudo yum install nano. Now I have nano installed on my system, so let's execute the command again, sudo nano /etc/rsyslog.conf. Let's scroll down and search for module load equal to imtcp. And here is the line, so I will uncomment this line, and I will also uncomment the input type. Sorry, this is not the correct line, so let's comment this again. So here is our line, module load imtcp. I will uncomment this line, and I will also uncomment input type imtcp port 514. Now let's save the file, and I will open or enable the TCP 514 from firewall D. So I will type this command, sudo firewall cmd --permanent add port 514/TCP. So what I'm doing here is that I am enabling or allowing access to port 514 on this server machine using the firewall command line. Now press enter. As you see, the output success, which means that we enabled 514 TCP port on the system. To apply that, I need to reload the firewall service. To do so, I will do sudo firewall -cmd -reload. It's also success, so we are good to go. After editing the main configuration file of rsyslog, we need to restart the rsyslog service. I will do that by executing sudo systemctl, then restart, then the name of our service, which is our syslog.service, or you can remove the .service. Press enter. Now our server is ready to receive logs. But first, let's check the status of our syslog. And from the output, you can see that the service is enabled and it is active and running since 13 seconds ago. Now we enabled this server to receive logs from other machines. We also enabled the rsyslog port from firewall D. Now it is the time to configure the client to send logs. So I will open the terminal for the client machine, and all steps or instructions I will do it here on this client can be done on multiple machines. Now from the client machine, let's edit the rsyslog config file. But first I will also install here the nano editor. So I will type sudo yum install nano. Now I have installed nano, so let's use it to edit the main configuration file of rsyslog, which is located under /etc rsyslog.conf. Let's scroll to the end of this file, and let's add our configuration here. So I will type ***, then add, and after that I will provide the IP of our syslog server. So from the Vagrant file, this is the server IP. I will just copy it and let's add it here. The double add here means use TCP. Now let's ensure hostname is properly sent with the logs. So I will take a new line and I will add those 2 lines here. Now let's break down what these configuration lines are doing, starting with the first line, *.* at 192.168.33.10. This tells Rsyslog to send all log messages. That's what the asterisks mean. And it will send the log messages to the remote server at IP address 192.168.33.10 using the TCP protocol. The double at symbol is how Rsyslog specifies TCP. This ensures logs are transmitted reliably with error checking, unlike the simpler UDP protocol. Next up is the action send stream driver mode 1. This line activates TLS encryption for sending logs. The number 1 here means Rsyslog will encrypt the connection to the remote server, protecting your log data from being intercepted or read by anyone else on the network. Think of it as wrapping your logs in a secure digital envelope. Finally, action sender stream driver permitted peer asterisk. This last line acts like a security checkpoint. The asterisk means Rsyslog will accept any certificate presented by the remote server during the TLS handshake. While this makes setup easier, it's a bit like leaving your front door unlocked. Convenient, but not the most secure. For stricter setups, you would specify a trusted certificate here instead. So for this one, I'm only doing it in our lab. Okay, now let's save this file. And to apply our modification, I will start the Rsyslog on the client machine. To do so, let's execute sudo systemctl restart Rsyslog.